The uranium, number of neutrons. Once again, you just take the mass minus the atomic number. So I want you to draw this note down real quickly. You need to understand that the proton plus the electron equals the neutron. So there's this constant battle. There are actually neutron stars.
Wait, so
They're
are
just
neutrons
neutrons?
the atomic mass?
Just pure neutrons. You would think that there would just be only neutrons in the universe, because there are neutron stars, but there's just a lot of dynamics out there that prevents that. But once again, protons like to bond with electrons to form neutrons. This is just an analogy here that I'm trying to help you remember it. These are the pieces to the puzzle. The electron is smaller in mass. Typically when you go to a store and you buy clothing, the smaller sizes are designated as small, but the plus one are the plus sizes. So if you get one, obviously, you add them together, you get the neutron. So quickly, it's hard for them to grab hold of the proton. But when you have a star that collapses, it kind of condenses the movement, so they're more likely to strike each other, and you get the neutrons. But just in a typical atom, the electrons are moving so fast, it's like taking a magnet and throwing it in a refrigerator. It's not going to stick. They're trying to stick, but often it doesn't. So up here, we've got the electrons flowing out of the negative and to the positive. So if we take this magnet, the question was,
Why is it?
Oh, it's not bad. I don't know a little bit off topic, but that reminded me. What are those like block things that have like orange lights in them?
neon?
Yeah.
Yeah. It's not similar to that. We'll see that in the future. When you burn metals, you get that particular color. You get a spectrum. Now, the important part of this lab, or this presentation, concerns the magnet. They were trying to figure out what was going on with the magnet. Nobody knew. And what J.J. Thompson did, he took the magnet, right, and he said, I wonder what will happen if I do this. And you can see how the magnet is moving the electrons. See how it's moving it? And if you flipped it, they're actually attracted to the other side. So it's attracted this way to the positive, and the electrons repel. So what did J.J. Thompson prove? That there are electrons in the structure of the atom. Because this is independent. This magnet is not, it's separate from everything. It acts on its own. So J.J.'s like, well look, if it's acting on its own, then the electrons must be in the structure of the atom. And from that, he proposed the first model of the atom, based on this demonstration right here, which is actually pretty cool. I know it's very simple, little simple demonstration, but it has enormous consequences. A mixture of metals. So alloys are magnets. Now the greater the difference in the alloy, the stronger the magnet. Like neodymium is the strongest magnets on the market.
Is it possible to make them stronger?
They're working on it, yeah. The stronger the magnet, typically you can make computers that are a little bit different. So if you're interested in magnets, do study that, because all of your computers are based on them.
Magnets are stronger. Magnets are bigger.
You can make them stronger with electricity. You can make electromagnets, but the core to it is the mixture of the metals, because you're creating, magnets trade electrons, or metals trade electrons at different rates. So let's say iron trades different than nickel. So that's how metals bond. They bond by trading. So if iron is trading with itself, it gives 2 electrons to itself, it takes 2 electrons. That's an equal trade. Does everybody see that? So equal trade doesn't set up a magnet. It's when the trade becomes unequal. Somebody has a positive and somebody has a negative. It's like if you have some trading cards, let's say you have baseball cards, and you trade with your friend got a better deal than you did on the trade. Well, he got the positive deal and you got the negative deal. That's kind of how magnets work. J.J. Thompson's plum pudding model of the atom states that the atom is uniform, positively charged sphere containing electrons. So the containing electrons comes from the magnet and its interaction with the cathode ray tube. And the picture you see right there is the first ever model of the atom.
Wow.
It was based on like an experiment that can be proven. So we did prove that model with this demonstration. So it's really significant to see that. All right, who wants to read for us? Why do electrons repel?
Because they're different.
No, the electrons are the same. So why do electrons repel?
Because they're the same.
Okay, but what about them being the same? I told you a few minutes ago that you can have a positive electron that will bond with a negative electron. So why do negative electrons repel?
Because two negative people don't make a positive. Because opposites attract.
Okay, you're close. It's really obvious when you hear the answer. You can be like, okay, that does make sense. The negative electrons do not form a stable substance. So when you try to push them together, they don't form anything. So because they don't form anything, they repel. So when the magnets are pushed together and you feel that repulsion, they're not forming anything stable, they're just bouncing off of each other. That's repulsion. That's most likely the case too with the graviton. We haven't discovered it yet, but if gravity were just a force of attraction, how large is the moon compared to the Earth? It's a quarter. Raise your hand next time, I'll give you points for that. So it is a quarter, the moon is a quarter the size of the Earth, and it's not, enormous distance from us. So our gravity should just keep pulling the moon to us. And part of the reason why it doesn't is because there has to be a repulsion happening there. So there's a repulsion between the gravity of the moon and the gravity of the Earth. Keeps it kind of in an orbit. It would keep it in a pretty similar orbit. The moon has been I don't think it's changed its orbit since it was placed there. You can check, it might have go in and out just a tad, but it's pretty close to its original orbit based on its mass. That would be a problem. Now is the sun gaining mass or losing mass? It's actually losing mass. Right, so it's going to eventually expand though and engulf the Earth because it'll change its density. Yeah, as it makes the different larger elements, it kind of expands out.
Well, I don't think we'll last 9 million years considering how quickly we're already destroying the Earth and having to make that long.
Okay, so write that in your notes. The sun will eventually engulf the Earth because it changes its what? Raise your hand. What change? What would?
Density.
Yeah, the density. All right, I got you. Amir.
Actually, you said it.
Jane? Okay, that's not the reason why they repel. You might know why electrons repel? They have a negative charge. That's not correct. All right, so let's read a little bit in the book. Yesterday we read a little bit about the cathode ray, so let's continue on with that. We got a demonstration on that today. So we talked about the conservation of mass. We talked about John Dalton, and you wrote down 2 things about his ideas of the 6 that we had in the book. He proposed that atoms are indivisible, indestructible. So let's read on page 107 where it says the cathode ray tube. Let's read for us. The red is considered to be what? It's the positive. And it's also considered to be the hot part of the battery, right? So here we're showing you with the magnet that electrons flow out of the negative into the positive, which is the hot part of the battery. Now the question is, why is it hot? How are batteries being, I guess you would say, evaluated, or how are they measured? What are batteries being measured on? Are they being measured on the push or the pull? No, they're being measured on the pull. The charge, that's why the positive is hot. So the positive is drawing electrons to it. And when that, I guess you would say, pull diminishes, the battery basically stops working. So you've got to be able to draw. That's basically the draw of the current is the positive. So batteries, how do batteries work? How do car batteries work? I know. They work by corroding metals. So inside your car battery, there's a metal, typically lead, and there's an acid, and the acid eats the lead up, and in that process you produce electricity. And the electrons typically, they're going to flow out of the positive and into the, correction, they're flowing out of the negative into the positive. That's how the flow works. And if you overcharge the battery, it can overheat and you get impurities that result. So up here on the cathode ray, this is very important to set this up properly because we want the electrons to be drawn through this opening and across the it's this filament so you can see them. So. Is a magnet an element? Are any elements magnetic? Raise your hand. Which element's magnetic? Hunter? Magnesium. What else? What else is magnetic besides magnesium? Cobalt? Sam? What do you think? Zinc. No element on the periodic table is magnetic. None of them are. We should have learned yesterday that the proton number is the same as the electron number. And because the protons and electrons are the same, you have zero charge. So every element on the periodic table has zero charge. None of them are magnetic. Now, when you take a metal like iron and you mix it with, let's say, nickel, you have two different metals and you have what's called an alloy. Write it down. An alloy is a mixture of metals. And alloys are what? They're magnetic. Raise your hand, you know. They're magnetic. So the difference in the mixture creates different types of magnets. Some magnets are stronger because the alloys are different. So what do metals do that create magnets? How do metals bond? Anybody know? We haven't got to that yet. It's called the metallic bond. Go ahead. It's called the metallic bond, but how do they bond? Okay, they bond with their electrons, but how do they do that? No, ionic would be sharing. Correction, ionic is not sharing. Ionic is a transfer. Covalent is sharing. So there's different methods. So the metals don't do sharing, which is like the females. The covalent, non-metals, oxygen. Women tend to share things more than men do. Like my wife, she used to share clothing with her sister, and I would be like, shouldn't you sell that to her? Guys think differently. So metals bond. How do they bond with their electrons? It starts with the T. They trade. Yeah. The ionic is the transfer. We mentioned that a few minutes ago. Ionic is transfer, where you metal transferring to a non-metal. So the metal bonds with the other metals by trading. There's a trade happening there. So metals bond with themselves by trading. So if you're iron and you're trading 2 electrons with yourself, that's a trade. Now, a lot of guys have experienced this when they're younger. They trade baseball cards. They trade bicycles. You know, they trade things. Now, is every trade the same or equal? No. And that's what sets up a positive and negative. Like if you're trading baseball cards and somebody gets the better deal, they got the positive deal, you got the negative deal. But when we look at it from a magnetic perspective, then the negative part is where there are more electrons found. So the positive is where there's less inside the magnet. So there's not an equal trade happening. One part of the magnet has more of the electrons than the other. Does that make sense? And that occurs because of the equal. They're not trading at the same rates. Iron trades at a different rate than, let's say, nickel or another element that's in the magnet. So that's called, what's it called again? Starts with an A. Raise your hand. Lily? An alloy or AC motor. And in the AC motor, you have, How many poles? You have two. So you see the north, which is the negative, and the south, which is positive. And in doing this, he created more electrons across the wire, and that created efficiency. Now, there's more than one AC motor. There's like a lot of them, but they basically all share one thing in common, that they have two poles. So people have been manipulating. Has anybody tried to put 3 or 4 poles in there? Yeah, they have, but the problem is you're trying to get the electrons out of the motor because the electrons are inside the magnet. Well, motors last forever, electric motors. No, they do tend to wear out. Your alternator, which is an electric motor in your automobile, lasts about 100,000 miles. And you're going to want to replace that after you get past 100,000 miles, because what will happen if you don't? Your car will stop working on the highway and you will have no power to power your brakes or your steering. So you're going back to old school 1970s trying to start your car. Going, let's say you're 70 miles an hour and you lose power steering and power brakes. So if you are driving a car that has over 100,000 miles on it and the battery light comes on, take the battery light seriously. First model of the atom is based on the magnet's interaction with the cathode ray tube. And I asked you at the beginning of the period why electrons repel. You might tell me why electrons repel, because you're seeing the repulsion happening when you place the negative part of the magnet on top of the cathode ray tube. So why do electrons repel? Raise your hand. You're close. In the future, if you're ever in a relationship and it doesn't work out, that's the idea. Electrons don't form stable substances. So when you try to push them together, they don't form anything. They just bounce off of each other. They don't form a stable product. Write this down. Electrons repel because they don't form a stable product. Only electrons are being introduced here, because that's only what was proven to be in the atom. Nothing else had been proven, so they could only draw basically a model of a sphere with the electrons in it. So he didn't know anything other than electrons. That's the only model that he could academically support with data. They call it what type of model? Plum pudding model.
Neutral from everyday experience. You do not receive an electric shock except under certain conditions when you touch an object. If electrons are all part of matter and they possess a negative charge, how can all matter be neutral? Also, if the mass of an electron is so small, what accounts for the rest of the mass in a typical atom? In an attempt to answer these questions, J.J. Thompson proposed a model of the atom that became known as the plum pudding model. As you can see in figure.
Okay, very good. So the cold medicine is 22%. So you divide it by 100 and got 0.22 times the volume that you have. So it's going to be around 55 milliliters what, Gavin? $55 milliliters of alcohol. So mass minus proton number equals neutrons.
Should I round it?
You can. Typically we do round it because you can't have half a neutron, half a proton. There's a...
Could someone calculate that?
Calculate it?
Yeah.
You should. So you got 238.
That would be it?
238 minus 92.
Have you heard of bipolar magnetic reversal theory?
Yes, the poles can switch, what Jeremy is talking about. So right now, our North Pole, electrons are flowing out. And there have been cases throughout our history where the poles can switch. It would cause a lot of problems with compasses. So you'd have a compass and you'd be thinking it's north, but now it's south. Would they switch this? Would they now call South America, North America? Probably not going to do that. They're probably just going to change the charge So the north would then be positive. But currently the electrons are flowing out of our north pole, and that's how they've got it arranged up here. But I do want you to understand that these can flip. Okay? So you might want to write down now they're currently negative. That's how the magnet is described. Now if you look at the diagrams, it's important to see that the electrons are flowing out of what? Are they flowing out of the positive or out of the negative? That will not change. The electrons flow out of the negative part of the magnet or the positive part of the magnet. They're flowing out of the north and into the south pole. They flow out of the north into the south. So why is that? Why are the electrons going to the south pole? Anybody? Mainly because they're smaller, the protons are larger. When we talk about a positive thing, we're talking about protons. So these electrons are going to be what's moving to it. Now on your automobile battery, the positive red part is the hot part. That's where the electrons are going to go. The pull. So that's why you're going to see a lot of voltage changes happening if you touch it with like a metal, a positive